Okay, we're going to work another question for constant acceleration. This is a graph. First thing we do, like in every question, is we write our equations. Final velocity equals initial velocity plus acceleration times time. Final velocity squared equals initial velocity squared plus 2 times acceleration times distance. And finally, displacement or distance equals initial velocity times time plus 1/2 acceleration times time squared. These are your 3 equations of kinematics. You always write those down first. The graph shows position versus time. So this is position, this is the x, this is time down here. For an object moving with constant acceleration, what is the final velocity of the object at time t equals 9? So t equals 9 seconds, we want to know the final velocity. And we know we can use these 3 equations because it's a constant acceleration. These kinematics equations, these 3 equations, can only be used with constant acceleration. Assume the initial velocity at the origin, so at that point right there, the initial velocity is 1.5 meters per second. So now we are trying to find final velocity. So we look at these equations over here and we say, okay, what equation matches up with these 3 variables? Well, we're missing a variable. You have to have 4 variables. So VF, yes. VI, yes. A, ooh, we don't have A. And T, we do have that. Okay. This one here, VF, yes. VI, yes. A, no, we don't have that. And D, no, we don't have that. So we come over here. D, we do not have. VI, we have. T, we have. Acceleration, we do not have. And T squared. So because we're trying to find VF, we only have 2 variables for all of these. So what are we going to do? Well, this is where the graph comes in. This is a graph of position versus time. Now, if we have an object moving at 1.5 and then it stops moving at 9 seconds later at this velocity, we know a displacement has occurred. It has moved a distance. What is that distance? Well, here's where we find it. We know at the origin the object is at 1 meter because that's 2 and that's halfway in between it. So our displacement is final position minus initial position. So our initial position is 1 meter because that's a meter. And what's our final position? We come over here to 9 seconds, which is right here, right there. We follow that up, and our position is it's right here, which we're going to call 17, but it's a little bit higher than 17. So I'm just going to say 17 meters. So our displacement then becomes 16. Now, if we relook at these equations, we're trying to find final velocity. And in order to find final velocity, we have our initial velocity. Yes. We have our acceleration. No, we do not. We have time, but we need displacement. So the easiest thing to do is to use an equation to find acceleration because there's acceleration in all 3 of these. So we have to find acceleration. So it's a 2-step problem, really. So the easiest way to find acceleration is this equation here because we know our displacement, we know our initial velocity, we know our time, we don't know acceleration, and we know time up here. We couldn't use this one because we don't know VF, and we couldn't use this one because we don't know VF. So we use this equation. So we're going to write it again to start our mathematics equation. Now we're going to plug them in. Our displacement is 16. Our initial velocity is 1.5. Our time is 9 plus 1/2 A, which we don't know, and our time is 9. That's 9 squared. So now we just get our calculator and we do some math. 1.5 times 9, I don't know what that is. It is 13.5. So I have 16 here equals 13.5 plus 9 squared is 81, and half of 81 is 40.5 times A. And I'm solving for A, remember? So I'm going to subtract 13.5 from here, subtract 13.5, 16 minus 13.5 gives me 2.5. That's going to equal 40.5a. So now I'm going to divide by 40.5 for both sides. So my acceleration equals 2.5 divided by 40.5 equals 0.0617. So 0.0617 is what we get for our acceleration. Now what we're going to do is plug that acceleration into one of these equations here to solve for my final velocity. And that's the easiest one, I think. You could use the other one and still get the same answer. So I'm going to write that down right here. VF equals VI plus AT. So my VF then equals my VI, which is 1.5, plus my acceleration, which is 0.0617, times my time, which is 9. So I'm going to go 0.0617 times 9 equals plus 1.5 equals, and I end up with my final velocity of 2.0553, so 2.06, I'm going to call that. Now, because it's a multiple choice question, the answers are multiple choice, we had to make some assumptions, okay? First off, how many significant figures should we use over here? Well, if you want to be technical, significant figures are only one because we have a 9 up here. But proper physics calculation says you need to keep at least 3. So I kept 3 here, I moved it over, and I kept 3 in my answer. But on a multiple choice, basically we're looking for the answer that's closest to 2.06. So if there's a choice of 3 and there's a choice of 2.25 and a choice of 7, then you want to choose the one that's closest to 2.06 because you never know exactly what significant figure rules, if any, they follow when they make the answer key. So the answer closest to this will definitely be the answer. Thank you.